Hey there, this is University of St. Thomas Math 005. This is Lesson 3, Part 1 for J term. And I want to get us started on 2.1. We've talked a little bit about degree, and we're going to be talking about first degree equations. Couple things. First degree means that you have some variable with either no visible exponent, or it's understood that it's an exponent. So I've got something like x plus 3. That would be a first degree expression. And if I were to say, okay, my x plus 3 equals -1, I could then solve for my x because I have an equal sign here. And this piece, this equal sign, is what makes the difference between an expression, which is just a mathematical phrase, into a sentence, mathematical sentence saying this thing is equal to this thing. So this is kind of the, well, it is the thing that makes it an equation. Okay, you can also have an inequality, which we will eventually get to, not today, not now. But we would be able to, again, go ahead and solve this by subtracting this 3 to the other side. I'm going to have x is going to equal a -4. And then we would be done. So we're going to go ahead. We're going to have a number of algebraic expressions that are going to be set equal to each other. And those equations are what we're going to solve. So let's get started on that. There's nothing terribly surprising about this. Most folks have done some of this already. I do want to make sure that we know, though, that there's not going to be any squares or cubes or any of that. This is going to be first degree equations. All right, so I've written down a couple of equations here, and we're going to talk about equivalent equations. So one thing that I can do here is I have my 3x plus 5 is going to equal 8. I can go ahead and subtract this 5 from both sides, right? If I do that, this positive 5 and the -5 are going to cancel out to go to 0, which is what we want. So I'm going to have a 3x, and then I'm going to have 8 minus 5, which is going to give me a 3. All right, so this equation is equivalent to this equation. And now I can take it one step further. I can divide both sides by 3. And so I'll wind up with x is going to equal 1. All right, and this is also an equivalent equation. All right, so any one of those is a part of the process of getting to find out what x is, but they are all equivalent statements. They're all equivalent equations. I'm going to go ahead and do something very similar with this one. I'm going to go ahead and subtract 7 from both sides. And then I'll have a 2/3 y equals a 2. All right. So 2/3 y, that's just going to come on down because I haven't done anything with the y's, right? I'm subtracting that 7 from both sides, which means I have a 2 here. Now, I have a 2/3 of something, and that's equal to 2, right? So I need to do something with this. I'm going to actually suggest we use the reciprocal and multiply. You could also just multiply by 3 and then reduce. That's fine as well. In fact, we can do it both ways just so that you can see how it would work. All right, so let's go ahead, and I'm going to scroll this up a little bit. So here I'm going to multiply both sides by 3. Right. 2/3 y is going to equal 2 times 3. Remember, what I do to one side, I have to do to the other, or it stops being equal. So that's really crucial to keep in mind. All right, so now I have a 3 divided by a 3, and that's the same as a 1. So I'm going to cancel these guys out, right? That becomes a 1, and this becomes a 6. So I'm going to have 2y, or 2y over 1, right? Same thing, is going to equal 6. And here, again, I can say, okay, this is an equivalent statement to the ones up here. And I'm going to divide both sides by 2 now. I'm going to say y equals 3. All right, so this is one way you could approach it. It takes a couple of steps to get there, and that's just fine. Whatever way works for you. Remember, this is about getting the correct answer. It's not about rushing through something and slapping down a number. Okay, we want the numbers to be correct. So the other way I mentioned that you could do this would be to multiply by the reciprocal of this 2/3. So I'm going to kind of jump back to where we were up here. I'm going to rewrite this. So it's 2/3 y is going to equal 2. And now I'm going to multiply by 3/2, right? This is the reciprocal, the inverse, multiplicative inverse is what we call it. And that's supposed to be a 2, even though it's kind of messy. So I have a 3/2 that I'm multiplying on both sides. Now, I'm going to change the color to make it real clear what's happening here. I have a 3/3, so I can cancel those two out. And here I have a 2/2, so I can cancel those out. So now I'm left with 1y. 1y, or just y, right? And now I have a 2/2, right? This is the same as a 2/1. So my 2 and my 2 are going to cancel out. So that's going to leave me 1 times 3. So we could have gotten there equally, equally quickly if you're comfortable with canceling. If you're not comfortable with canceling, do it the longer way. It's no big deal, right? This is about getting to the correct answer. So I'm going to say, let's pause here. I'm going to go on and resume in the next video, and we'll talk some more about first degree equations.